We called this meeting because around 2 weeks ago the town contacted ROWI and told us that we have fundamental problems with the infrastructure of the water system. So they asked us if we could get the community together, Water District number 2, which is Windmill, and we would all come out and they would make some presentations for us, tell us what's going on, educate us, learn where we are now and where to go from here. So with that, Supervisor Arden is here to run the meeting and to present everybody and let us know what's going on. So I'll turn it over to him.
Hi everybody. Good to see everybody here tonight. About a month ago, we had a presentation by an engineering firm that Sal from the Water Department had hired to study the Water District 2 and the pipes. So a month ago, we got this report that you're going to see shortly, and frankly, it was pretty alarming. The study was commissioned last year, and it just, as I said, came out about 4 weeks ago. And as we watched it, the board realized that we were in the final stages of paving a number of roads in Windmill, and some of those same roads were roads that had water pipes that also needed to be replaced. So we realized that we were in a situation where we might have to tear those roads up very shortly after paving them. We felt that was not a good idea, to put it mildly. So, so both projects were started last year, but they're sort of coming together this year. So that's where we found ourselves. And the study was done by a company called GHD Consulting, and I think you'll find it very revealing. You'll see it in a few moments, like I said. The good news is that we're able to hold off the final paving at this point, and so we wouldn't have to dig up roads that we just paved. The bad news is that Water District 2 would be in the situation of having to pay for a lot of new piping and new expenses. We understand that there has been some concerns among residents with the health of the distribution of the water, and we want to make sure that everybody understands that the piping, which has a 50-year life and is part of the reason the study was commissioned because it's coming to its end, it's actually asbestos cement piping called transite. And just so you know, I'll go into briefly about that. Transite pipe were very widely used in the 40s and 50s throughout Westchester County, throughout the rest of the country. In fact, about 15% of the entire country's water distribution pipes, about 136,000 miles of piping, was transite pipe. There is no known evidence that transite pipe has ever created a health hazard. And in fact, Bob and I have had 2 discussions with the county health department. Bob actually had one just a few minutes ago, and they again confirmed that there is absolutely no danger from using this piping as far as water pipes. The only potential danger is when you have a break and the workmen have to cut it. If the asbestos could go airborne, that's the only issue that you'd ever have. But there's no danger to residents drinking water going through those pipes. And our pipes, because of Sal, have been tested on a regular basis for the last 25 years. And the amount of fibers in the water is so small it's almost undetectable. So I just want to make everybody aware that that is not an issue in this situation. Like I said, we've been testing it for the last 25 years, and there's really no issue whatsoever. Based on this data, it seems certain there is no health risk to the water users from the transite pipe. However, I mentioned that there is some danger if you are removing the pipe or you're servicing it. So that's one thing we want to be concerned about. Today, the piping that is used is an iron, a ductile iron piping, which is what is being used throughout the rest of the country at this point. To replace all the pipe is obviously expensive and has a financial impact on Water District 2. We are working on a myriad of engineering and transmission issues, and ultimately the cost to do whatever we find is the final best answer for the Water District. But without question, replacing the transite pipe, without question, will be a multi-million-dollar project to replace all the transite pipe. Just want everybody to know that up front. As in the case of previous District 2 capital improvements, on Evergreen Road, the water storage tank, 3 years ago, the capital expense can be paid by issuing municipal bonds. A sliver of good news is that right now 20-year bonds are at the lowest rate they've been probably in a generation. Our last bond went out at slightly under 3%. That equates on $1 million to about $67,000 in interest a year, 372 customers in the district, so it comes down to about $181 a family per year, per $1 million. So if you have to spend money, you have to bond it, it's a good time to do it.
Is that equal interest or even what is that?
That's interest and principal.
Okay,
Oh, and principal.
Yeah.
Yes.
Do we have any idea how many millions it will be, though?
Let me go through this and then those questions.
250 million.
We'll get to that presentation. Okay. It'll take a few months, including a public hearing with the residents of Windmill, and a lot of engineering studies and reports. The district has presently about $560,000 in cash reserves that can be used to start the engineering and legal expenses to do the studies and get to the ultimate decision. North Castle Water Commissioners will make the final decision based on input, obviously, from you and all the technical people. The Water Commissioners are, in this case, your town board members. As for the current conditions of Evergreen Row, North Lake, and Pond Lane, in the past 3 days, Bellata, who is the paving contractor, has improved the conditions of the road to make it more serviceable and safe and be able to withstand the coming winter if we have to go that far, which we think we will be. Improvements will also be made to driveway cuts to eliminate the uneven conditions, and that at the end of many home driveways will make that so it's drivable and safe.
Excuse me, Howard. My name is Rick Wolf. I've been in Pond Lane for 25 years. How is it possible that the town board, the highway department, and the water people didn't know about the problems with the water pipes? So these guys, Bellata, went ahead and started to repair our street. We have all sorts of problems with, again, you just mentioned the street being cut now, so you ruin your tires in your car. How is it possible this wasn't known a year ago, that they didn't say, let's not do this right now, we have to go and check the pipes first?
Can I make a suggestion?
Yeah.
That's a fantastic question,
Yeah.
but I think this meeting will go a lot easier, probably a little bit faster, if we let them go through the presentation first and save the questions until after, because otherwise I think we'll lose a lot of traction in getting to
I agree. We'll lose our continuity, and actually, that'll come out in the presentation as the sequence of the studies that were done. Okay. Okay, so we'll be fixing the curb cuts and driveways so that won't be an issue as far as ruts and bumps and that sort of thing. It'll be drivable, and it'll be safer for people to use the roads. I know you have a lot of questions and for the town officials, but I think the most productive to hold your questions at the end. You'll see the presentation. At the end of that brief slideshow, we'll be happy to answer as many questions as possible. And I think you'll find that the presentation is very informative. So,
Howard, may I make a suggestion? Why don't you introduce the town officials that are here, so everybody knows in the room who's presenting, etc.
Okay, very good. I assume when I have the town board who's here, why don't we stand up? Diane Roth, John Cronin, Steve D'Angelo, and Mike Shirley will be here, I guess, shortly. He said he's coming a little late. And as far as the engineering folks, Jan, would you like to introduce yourself?
Jan Salzman with GHD.
And Sal Dissy, who are our water commissioner. Okay.
Mr. Gordon, I'm sorry, I don't want to ask a question, but Mill Lane and Pond Road, I think, water break.
There's a water break right now.
Mr. Salzman, I'm a professional engineer. I've got 27 years of experience or so in these types of projects. We conducted a study on your water system, and that's what I'm going to present to you today. I'd like you to kind of hold off on your questions at least until I get through it, and then we'll have some time at the end. I'll try to keep it brief.
Can I just, before we start, Howard mentioned that we commissioned this study last year, which is true. I just want to let everyone know how this really came about. We've been doing some improvements in Windmill over the past several years. It started back in 2007 with a new water storage tank, and at the other end, at the same time, we were putting in a new water supply, a new well. In the middle of, or early last year, late last spring, That new well finally came online with new equipment and new controls. It was designed to move a certain capacity of water, which we have an abundant amount with the new well, into the system. What we found, and I don't know if a lot of you experienced it all last summer, but we went through about a month-and-a-half period where we had constant water main breaks, sometimes 2 and 3 a day, and it just didn't stop. I was approached by many residents to ask what, and this isn't anything new. These pipes have been this problem as long as I've been working here. We constantly have had these problems. An approach to it would be do a study on the system, a hydraulic model, which is taking actually the size, lengths of pipes, the type of pipes, where the valves are. Jan's going to show that in his presentation. And they put it into a computer model and run the software and give basic sequences of what could happen if you have this pipe break and this pipe break, and it flows based on hydrant flow capacities. And really, the idea was to find where the weak points are as a place to really start. You can't just say, well, we're going to just replace Pond Lane, because what about the other areas that if you replace that, you could have problems in other areas. But we wanted to look at the whole system, see what the issues were throughout the system, and then make a determination and a plan for the future, because this pipe, as all pipe, approaches its useful lifetime, and we're getting close to that. So, Jan, with that, please. Okay.
So first, a little overview of what we're going to talk about. We're going to go into some background, existing conditions. We're going to talk about the purpose and the scope of the study that we did, so we kind of understand why the study was done. Then we'll get into the findings, finally recommendations, and we'll save the best for last, the cost estimates. This is just a map of the district you should be familiar with. Here's some facts about it. Of course, it was built in the 40s by developers. Something to note, back then they did not have the rigorous approval process that they have today. Today you have to get plans approved by the county health department, and DEC has to be in on the construction, and it's a fairly involved process. None of that really existed back then. The contractor didn't have as many controls on it when we installed the system originally. We'll talk more about that in a little bit. There's been some recent improvements to the district, as Sal just mentioned. The water tank, pressure pump, new controls. You've probably seen this tank in the neighborhood. But there's some concerns with the district as well. There's been a history of water main breaks. And as you just heard, there's one this evening. I'm sure it was not planned. It just happens that they're so frequent that it's it's coincidence that it happened tonight. As I said, the developer didn't go through this rigorous approval process when he put the pipes in, and in Sal's efforts to restore some of these breaks, he's been in the ground and he's seen the pipes, and he's found that there's issues with the way the system was constructed, poor construction techniques. And we'll talk about that a little more too. Some of the materials that were used, pipe bedding and so on, not up to today's standards. So why do a study? Well, the main idea here is to identify the problem areas and seek out the weak links in the system, rather than just go in and start tearing up all the pipe, which could prove to be very costly and possibly unnecessary. You want to strive to find what improvements we could do, what kind of condition the system's in now, what kind of service it provides, and basically develop a plan to make these improvements so you get the best bang for the buck, as I like to say. The scope of our study and the approach that we took. First we collected data, and then we constructed, with that data, a computer-based model of your distribution system. Then we used existing hydrant flow data to calibrate that model. So now, at least theoretically, it represents reality and has been calibrated to real-world measurements that were made in your system. The next step, we performed a series of simulations, and I'll give you some more detail on that in a little bit. Finally, analyze, evaluate all that information, and come up with some upgrades that can solve some of the issues that we uncovered. Then we model the upgrades. So we take the computer model, which was built to represent the existing system, and we model the modifications that we're proposing to do, and then we run more simulations to see if it really solved the problem. Finally, another step of this study was we collected a lot of historical repair data from Sal. He's kept good records about where the repairs have been, where he's had the most issues, most problems, most repairs, and we incorporated that information into the study as well, and finally generated the recommendations based on all that and developed some cost estimates. So I want to talk a little bit about the type of evaluations that we did, the type of information that we can get from a study like that. And the first batch of testing that we did is to test fire flow. So there's about 74 hydrants, fire hydrants, in the system. So using the model, we were able to open up each hydrant, simulating it in the model, and the computer outputs what the pressure and flow is. We compare that information to a criteria that we developed from standard sources. Okay, and I need to point out that this is not a criteria that we're not dictating what is your required fire flow. We don't do that. We're not insurance people. But the Insurance Services Office puts out some guidelines, and 10 state standards for waterworks also does. So based on that, on those standards, we developed a criteria of 500 gallons per minute with at least 20 psi remaining in the rest of the system. It's important to maintain a minimum pressure in your system at all times, because that is your protection against contaminating the system. So in this case, standards say 20 psi. And what I mean is, if you've got a positive pressure in your system, then things can't flow into the system. For example, let's say groundwater in a broken pipe or a leaky pipe. The water will leak out of the pipe instead of the contaminated water getting in and contaminating the system. Similar things can happen in certain plumbing fixtures, older ones. So it's important to keep that barrier to keep your system from becoming contaminated. All right, so we tested all the hydrants against this criteria, and then we adjust the model to see if we can improve the results that we're getting. Line breaks is another analysis technique that we do, where we look at all the lines and we simulate breaks in certain places. And then we see how many users would be out of water. For example, if a certain line breaks, maybe 50 homes lose water. If a different line breaks, maybe only 4 or 5. So in this manner, we're able to develop or identify lines that have a high consequence of failure. Finally, another batch of tests we did was just pressure and flow. By running simulations, we're able to determine what kind of pressures and what kind of flows are going through the pipes themselves. And that tells us information about the condition of the pipes. Because the pipe, the smaller the diameter, the smaller size of the pipe, the less flow you can get through it, and the more resistance there is to flow, which gives you more pressure loss through that section. So using these techniques, we're able to look at these various pipes and identify where the problem areas are. Finally, we collected data on the repairs that were done and analyzed that to identify where the most problematic areas were. So here are the findings. From all these efforts, we were able to determine that there's really not adequate fire flow in the hydrants in the system. You do get some fire flow, but they failed to meet our criteria, which was 500 gallons a minute and 20 psi during peak flow periods. We also found that a lot of the mains were undersized. There's some 6-inch mains and some 4-inch lines, and they're undersized. A lot of the pipes are corroded, which increases the restriction to flow and increases pressure drops. We identified some problem areas from the maintenance and repair records, and we're also aware that there's areas where very poor construction techniques were used to build the system. And I've got some photographs coming up. We'll talk a little more about that shortly. Here's a perfect example of how you don't build a water line. Now, typically the water line, when it's constructed properly, is encased in a uniform stone bedding, and it's compacted. Sometimes sand is used, but it's a uniform material. This means that the pressure on the outside of the pipe from the soil is even all the way around. In this case, you can see that there's a large hole in the pipe. That's because this rock was sitting on top of it. And that's a perfect example of a poor construction technique. Over time, as the rock settled through the soil, it broke the pipe, and you got a break. Here's another example of poor construction technique. These two pipes have different sizes. And so to repair the pipe, Sal has to stock a wide variety of different types of clamps and fittings and things to make these repairs happen. Some more pictures. One thing you can notice here is that how deep the line is in the ground. You have to bury the line at least 4 feet in the ground to protect it from freezing, and also to protect it from, say, pressures of traffic driving over the top. You can see the clamps, the yellow arrows are indicating clamps that the water department had placed on the line. Ms. Al, if you want to add anything on these repairs since you were there, feel free to speak up. Here's another example of the poor construction technique. This is a house service, a lateral here, and that goes up to somebody's house. This is the main line. You can see there's already a few clamps on it. You can see that the tap into the main line is through this big cast iron T. That's not how it's done today. It's done using a corporation stop directly into the line. So this is really not the way that things should be constructed. Okay. Finally, recommendations. Now, the easiest recommendation is just replace the whole system. But the reason we did the study was try to limit the scope of that and see what can we do a little bit to have a big impact. So the way we approached it was we prioritized our recommendations. So priority 1 are the things that we felt should be at the top of your list. Priority 2 after that, and then priority 3 more long term. Priority 1 recommendations were intended to improve the fire flow situation. Now, remember how we did this? We modeled these improvements. We went into the model that represents the existing system and made changes, and we played around with different changes till we got the best results with the minimum amount of modifications. Priority 2 was to improve reliability. This was based on 2 things. This was based on the history of repair records, where the failures were, and it was also based on lines that we identified that had a high consequence of failure. Finally, priority 3, all the remaining pipe in the system. We took the priority 3 pipes and we ranked them in order of the ones we felt had the highest likelihood of failure. And we identified the likelihood of failure based on a couple of things that we found out. One is the materials are constructed of. We'll get into that a little bit. And also the ones with the highest internal pressure. Because the more pressure it has inside, the more stress is on the pipe. So if you have a pipe that's made of poor material, that's poorly constructed, and it's under high pressure, it's got a higher likelihood of failure. So this is a summary of prioritized system improvements, and I have this on a handout. that you can take home with you. And got a board out in the lobby too. Get a closer look at it, see the street views. Priority 1 is about 10,000 linear feet. That's your fire flow improvements. Priority 2 is your reliability improvements. That's about 10,000 linear feet also. The remaining pipe, about 24,000. So you've got 28,000, I'm sorry. It's a little out of focus this one. $28,000. Now, there's been some talk about asbestos concrete piping, transite piping, and that's a material that was used, widely used, in the 1940s, 50s, 60s, and a lot of water systems have it. The life of that pipe, the design life, is 60 to 80 years. The design life of a cast iron pipe is at least 100 years. There's pipes in Westchester County that were built in the 1800s that are still in service. They're made of cast iron. Today we use ductile iron pipe, which is similar to cast iron, and it's cement lined. So over time, if that lining wears away, the pipes can be relined. So you really get a really long life out of the ductile iron, cement lined ductile iron pipe that we use today, as compared to this transite material that was commonly used in the middle of the century. So what I tried to do here is lay out how much transite pipe, or ACP stands for asbestos concrete pipe, in your system, and there's about 37,000 feet total. The amount that's in priority 3 is about 24,000 feet. We've got about 13,000 feet of it within the priority 1 and 2. So 13,000 of that 20,000 is asbestos concrete. These numbers are rounded because we don't have a survey yet. So we're going off things like GIS mapping, and it's not quite as accurate as an actual survey. That's why I've got these round figures up.
Is all the piping ACP piping in the system?
No, it's not. We believe about 37,000 of the 48,000 total is ACP.
And the remainder is made up of?
The remainder is cast iron, ductile iron, and copper. So it's a mixture of things.
Why is it different? Just replaced?
Sorry?
Why is it different? Was it replaced?
That's the way we believe that's how it was constructed by the developer who built it, the contractor who built the housing development.
Where do those water lines run? In the street or a shoulder?
Most of them are in the street, I believe. As I said, we don't have a survey yet, and we have fairly limited information. We'll get to the questions in a minute here.
You know that there's no water in Windmill now?
Yeah.
Yeah.
We were notified.
Is that in all of Windmill?
All right, so here's what you're laying for. Preliminary opinions of cost. Okay, remember priority 1 is to restore fire flow. Priority 2 is for improving the reliability, reducing the number of breaks. Priority 3 is everything else. There is asbestos pipe within all 3 of these. Okay. So these are, I'm going to call them very rough estimates of cost because we have limited information as to what's actually there. We don't have a survey. We don't have soil borings. The cost is very much, the construction cost to replace is very much dependent on the amount of rock that's got to be removed. So now, when we do our initial phase of design, we'll go out and we'll do a subsurface investigation where we bore holes in the ground and do some other things to try to identify how much rock is there. It's less expensive if you know ahead of time where the rock is and how much is there. Then
It's important to tell everybody here that the goal of this project, where we replace, the goal is to try to use the existing trenches where the existing pipe is. That would minimize a lot of rock removal.
What happened to the existing pipe that's in the ground?
That will stay live until you change over to the new pipe and then be left in place.
So the asbestos piping stays in the ground?
It's the easiest way to get rid of it. Does that make sense? It's the easiest way to get rid of it.
Let me interrupt a second. This is Bob Butterworth. He's a senior partner at GHD. He has 40 years or so experience.
Not quite.
My age. Well, if you consider all the overtime he worked, how much experience? All right. So if you want to come up, we're going to have some Q&A.
You're doing great.
Another slide, maybe help out. Okay. All right. So, looking at interest rates, and this is very generic information, but just to give you an idea, if you can borrow at 3%, this column is 20-year, this is a 30-year. At 3%, this is about the cost per $1 million for $1 million. It's cost per household.
Per month, per year?
Annually. So that's the yearly. Yes, that's interest and principal. That's what we would project the cost per household to be based on each $1 million bond.
So let me ask you a question. So what's the line between where the town pays for stuff and the water district? So if you're repaving the roads, the town pays for that, right? When you repave the roads, the town covers that. So why not utilize what the town's doing at the same time to minimize the cost? So if you're going to repave Evergreen Row, let's replace the pipes on Evergreen Row while you're repaving. Let the town do as much as they can, so I don't have to pay for it. And then I'll pay the delta to replace the new pipe.
It's two different jobs, and they would have to be done separately. Obviously, there's some cost savings if you do them together, but the water district obviously pays for the piping. But that's the idea. That's one of the reasons you're here tonight, is to try and coordinate this.
Right, well, because we have 3 roads that are being repaved now. I don't know how it fits on your map, but it seems to me we can do those 3 roads first, have the town bear a lot of that cost because they're doing the paving anyway. And then it should shrink this bill a fair amount, I would think.
Well, unfortunately, paving the road doesn't dig a trench and doesn't lay the pipe. That's a whole different job.
Can the highway department dig the pipe?
No.
They can do that?
It's an engineering job, an engineering company. It's actually, the highway department doesn't do that anyway. They're not licensed to do that. You have to hire a contractor who's licensed to lay water pipe. Now, we're fortunate.
Howard, what's the cost per year currently to fix the brakes? Does anybody know that number?
I'm not sure. Sal, do you have any? Where's Sal?
There is no exact number, and we budget funds and
approximately. A range.
Last year there were 15 brakes.
How much did it cost per brake?
On an average, $1,000 a brake.
So you're talking 15,
you know, that's
20?
a rough number. Some, it depends how long. Some
Okay, so it's twice as much as 25 or 30 grand a year.
Not quite that much.
Okay. To just fix it.
Just repair it.
And
then when we repair them, we also have to repair the roads, we pave the roads.
But that's paid for by the town.
No. We have a water break. We have to pay the highway department for the blacktop, for them to come in and put the blacktop in. The water district, because it was our water. So if there's a problem with the road, when we have to excavate and repair it and repave, we pay them for the material for them to go put it back in.
But substantially less than this program, right?
Yeah, but you're dropping property value when people find out that you have asbestos piping will more than make up for the $2,000 a year. I can tell you that.
That's not true.
I don't know that I'd buy into this neighborhood.
Well, we've all bought. It's been there for 40 or 50 years.
Nobody knew about it, though.
So you know about it now, and they're telling you it's not a health hazard.
Tell that to somebody.
That's the kind of talk that will affect your value.
Bob, one of the other issues that I thought was most important when I saw the presentation is actually the water pressure there's an issue with fire prevention.
Right.
And I think that really is the key thing here. There was actually a house fire that they didn't get enough pressure to put water on the fire a few years ago, and they had to put a pipe all the way to the lake. So that's really a critical thing, and that's priority one area. So that's probably more important.
I'm just trying to put it into
Yeah,
perspective.
sure.
What's the relationship between this project and the new curbs that were installed, and are they going to have to be torn up if this is?
Well, there's obviously a direct relationship because they're being both done sort of the same time or were, but the curbs will not have to be torn up because they would be able to go underneath them or away from them.
If the priority of this project is the fire flow, how do, Windmill has changed drastically over many years, and there's a lot more sprinkler systems to keep everybody's grass nice and green. How does the fire flow study, were those sprinklers taken into effect?
Generic answer that we take our peak daily flows based on our actual production records, and then you calculate your worst case scenario. So it would be the hottest day of the year with your lowest tank level, with your biggest demand and your biggest demand day, and then they plug that into the model, and that gives them what the equivalent flows would be in various parts of the system. That's how it's calculated.
Many times in the summer,
Oh, absolutely.
there was no water.
One of the problems in Windmill with fire flow was there was a number of 4-inch deadhead areas. Is this project going to solve some of that? Is pipe size going to be increased where you can't link it, or I assume your model is going to take care of some of that?
I'll just show them that one place, Ken, where we did put the link in.
The end of the bottom of Evergreen Road
Right.
was never connected to North Lake Road for some reason. It's a dead end. It's a dead spot, and the plan would be to connect that and create a loop which would help flows. When you increase flows or help that flow capacity through mains, you're relieving some of the back pressure on other mains. So it can only help improve things.
The model showed that this is one of the best places to put that link that you were talking about, right there.
This is an open loop right now, but our recommendation is to put in, it's about 300 and some odd feet, we close that loop.
Where is that? It's hard to see it from here.
Where that road, North Lake Road? You know where it turns into?
It's in a street, it doesn't go through a person's property.
Yes. And now we're open for Q&A. I'm still curious. I mean, for years, we waited for the roads to get paved on Pond Lane. And now our dream has come true. I mean, it's every day when I drive off to the station, you know, there's a huge drop-off. I know you said they were going to fix that. I hope they do soon, because my tires are taking a beating. There's a giant lake now on Pond Lane whenever it rains. And now you're telling me it's not going to happen until November, maybe next year? I mean, how is it possible that the town wasn't aware that they were doing this study, and at the same time they hired Malata to tear up the roads and do paving? How could that happen?
Well, again, both these projects were contracted for last year, so I don't have firsthand knowledge of that. But I think it was a matter of road study was done, roads were prioritized as need, and roads were chosen, and then the almost the sequential with that Sal started the water study, which took, Sal, how many months did that take?
We actually started last December.
Okay, so, you know, almost 6 months.
So if Sal was doing the study last year, why was Malata then commissioned this year to start tearing up the roads, to put curbs in? How could that happen? How come that be such a lack of communication on the board to not know what the water department's doing and the highway department's doing?
You would have to go back and ask the board from last year.
There's board members here from the board last year.
Well, to be honest, I mean, I answer for everyone, but as soon as we got the water, I said as soon as we got the information. Okay. As soon as we, it's very polite of you, but as soon as we got the information on the water study, we put the brakes on the road paving. As soon as we learned this.
Last year they were doing this stuff. This is not like a town.
What's that?
How come you guys didn't know this last year? when
Here's really what happened. Look, you know, you've lived there a long time.
Yeah.
You know you've had problems on your road. There's been many breaks on your road for years, and it's always been a problem. We can't just go in and just say, let's just go replace Pond Lane. You can't do that.
Let me
Let me
My
explain.
point is, how come there's nobody talking to each other in the town?
Let me explain to you the events that took place. We did significant improvements to the system. We spent a lot of money. We spent almost $2 million. We built a new water storage tank. You put in a new well. We just finished the controls to get the well connected to the system. Once we started to operate that last year, with all the new, and the more volume we could put into the system couldn't handle it. We were having breaks 3 a week.
Why didn't we know that? Why didn't we know that when we put the new stuff online, the sequence of events here?
What do you mean, what do you mean?
Well, you put in a new well, you put in a new tank,
Yeah.
you put in new pumps.
We needed to put in a new well because we needed the capacity because of all the irrigation.
Understood.
systems and all the problems.
But don't we take a look at
We
the
needed a
system?
new water storage tank because it didn't pay to rehabilitate the one we had.
I understand what you're saying.
Okay.
But Howard started out by saying these pipes have a 50-year lifespan. Do the calculations of the math when Windmill was developed. It's about 50 years. Shouldn't we have foreseen this problem coming when we brought the new system online? Isn't there, you know?
Well, I guess the thing is the most important part at the time was that the water tank that was in service was in need of repair.
Okay.
Now it didn't pay to repair that tank.
Okay.
Because there was only 200,000 gallons stored.
Right.
So we went to the next step and we put in a standpipe which would give more storage capacity in the event of a fire. All the houses have changed up there.
Sure.
They're doubled in size most of them over the years. So you need the extra volume, so we put in the water tank, and we knew we needed more supply, so we looked at putting in the well, and the well was constructed. Took a long time to get that approved through the regulatory, and then last year, there was another bid to get everything connected with the new controls and all that. We're actually not even able to use the system to its capacity because of the piping. Because we could have a lead lag situation with our booster pumps, where you get to a certain level in the tank and you need more water, it can kick on the second pump. The controls are there, we had to modify the computer in the control to tell it not to do that, because it would just break even more mains. We had to kind of wean it back, so we're not using it to the best of its ability. So we know that there's a weak link in pipe, but you can't do everything. You know, so you have to have a planning, you know, some sort of a plan going forward. The pipe is getting older. We know it's going to reach its useful life, and we need to plan ahead. So we're doing the study to get at least a basis of what we're looking at. I had no idea. You can't just say, I had a lot of residents, you know, we had a lot of people come when we had the breaks, and why don't we just throw a new pipe in here? You can't just do that.
It seems like we're kind of in an emergency situation right now to replace this piping. And I agree with you, the planning beforehand, but it seems like we brought on a new system with a new water tank. I understand why we need the new water tank, and obviously we need the pumping and the distribution that goes along with it. But if we didn't have the pipes to distribute it, we're not really getting the full value of what we put in, right?
We really didn't know that until we did the study. That was the point of the study. You know, so that, you know, we knew we needed the storage.
Right.
We knew we needed the well, or the capacity. And then we had to look at the pipes.
What size are your pipes?
Well, they vary in size, but most of them are undersized. By today's standards, the minimum size you can put in by Westchester County.
What size are they now?
The majority is 6 inch.
4 to 6.
6 inch. 6 inch.
The
The
what
minimum
size are you going to
required.
put in?
And they should be 8 inches.
Should be 8 inch.
Should it be 8 inch?
Minimum
Right.
is 8 inch.
So you knew when, and over all the years you've had all the breaks, you knew you had bad water, bad piping. You knew you had an undersized pipe, and you knew you had breaks all the time.
I don't think
So-
it doesn't seem to, it doesn't seem to be productive to you know, to focus on how we got here. We're here, and I think we need to figure out how we're going to move
The
forward.
conclusion is, and it's been for a long time, we have to replace the system. Now the question is, how do you replace the whole system?
Well, I think that's what they're trying
You
to
spend
tell
$2
us.
million replacing tanks and water wells? Or do you look at the whole system before you replace anything?
Well, I think that's why the study was commissioned.
No, if the study's been done after you already spent $2 million.
Okay, I want to be fair. You guys have done a couple good things, the water tank and the pumps and things. And, you said before that the pipes were 50 or less, and this gentleman said 60 to 80, so I'm trying to figure out which is accurate.
It depends what source you're looking at for that information.
What I live,
Difference of opinion.
okay, my home was built in 56, so let's get into that point anyway. But I'm a little bit curious, before unfounded rumors are caught, I'll take you at your word. You're saying that this is not a health problem, not a health hazard. On what basis do you say that? Was there a study done like this gentleman did? Were there 2 studies done?
Absolutely.
Where
Absolutely.
are those studies?
Well, the health department has studied it continuously. In fact, we were on it with the commissioner this afternoon of the Westchester County Health Department, and we went through the whole scenario. Sal has been doing water tests. How many times a year, Sal?
We've been doing once a year, once every 3 years in the wells, and I have a handout that explains everything about.
Yeah, I read your stuff all the time when you send it out.
Well, this is addressing the AC pipe issue. I've got a handout for if you want to take a look at it.
So we don't have to worry about what this gentleman is saying. You're prepared to say that tonight. That's not a health hazard. We don't have to worry about property values and unfounded rumors occurring about the water. You're prepared to say that tonight?
Well, I'm not a water expert.
Well,
They're the water experts. I'm telling you what we were told.
Okay.
Okay?
Told or studied? Was it told or studied?
Excuse me. Excuse me for a second. Sal, maybe you want to tell everybody about the EPA guidelines and about how many asbestos fibers per million liter are allowed to be, different contaminants that are often found in water. Perhaps that would be good.
And the property value is not on that there's asbestos in the water. It's on the capital improvements. I mean, $2,000 a year. People aren't going to want to spend that kind of money going forward at a higher interest rate. Right now, the interest rate is low. Now's the time to fix it, not when the interest rate is 9%. Then it's going to be $5,000 a year. It's going to be much harder to sell your home when you have to tell somebody that they're going to spend $5,000 a year. So just to be very clear, it's not based on a health concern. It's based on economics. With the interest rate.
Before we move on.
No, we're saying there's not a health issue here.
Yeah, I'll just give you, the EPA has set a guidelines of 7 million fibers per liter. That's their limit of what they say could be in water. Now, you have to check even your well water because asbestos can come into the water supply through rock. It's a natural mineral that we have to study and look at, and we're required to sample for once every 9 years or whatever in your actual water supply. Our actual averages for all our sampling, we're actually less than 1/10% of that standard.
The standard is 7.
7.
And we have 0.19, right?
Less than
0.19.
It's pretty much unmeasured.
0.019.
Yeah. 0.019.
Actually, they measured it, I believe, at both places, and they had different.
So you
they
have
had
every
the same
comparison. If you see the water quality in the well, you're getting the same water quality in the distribution system.
Have you measured it right after a main is broken?
Well, what happens right after a main is broken, that has happened, we have done that. But the thing is, right after a main breaks, there's a procedure we have to follow. We flush and clear and sanitize and all of that. And what happens is, if you have to sample for that, it's not like a litmus test where you can just check and see if it's there. You have to get bottles, you have to ship them.
Can you bring them into 38th Street in New York City?
It takes weeks to get something.
5 days.
Yeah.
That's water without,
What do I do?
5 days
Turn
without
everybody's
water.
5 days, you look at the
A
sample
little
back.
tricky.
You can't really, you can't do it. So there is no real requirement.
Well, but Sal, can we, with this break that's happening tonight, can we test the water? Right now, you're closing off that section that's broken, I assume. I have no idea what you're talking about.
I'm trying to call them, yes.
Right, if you close off that section, the adjacent sections have been impacted by that break. So can we test homes on either side of that break?
Right. What happens is, just so you know, where the break is right now, from the little bit that I know, it's on Mill Lane. So we have to do when there's a break, we have to go shut the pumps off so we don't break more pipes when we start closing valves. So what happens is now you still have water in the storage tank. That pressure from the tank is pushing water out of that break. Now what happens is we isolate it, and now it's contained. So you have, and then we have to go in and repair it. Now what happens is after we make the repair, we flush out whatever might have gone in there, and then we sanitize whatever repair parts we put in, and then we flush out what might be in the main as a normal procedure. We could check in the area if you want after we have this break, and we could certainly take a sample.
I think we should have, I think the water district should take samples from homes in the area after the break and see what the contaminant level is compared to in a steady state scenario.
We could do that.
You know, I think I'm frustrated, and a lot of other people are in here, about sort of the process and the way it's been handled. I don't know if anyone in this room, frankly, is responsible for that, because competent planning should have been on top of this issue and the roads and coordinating them 5 or 10 years ago, probably, frankly. So what I think is actually more important today is to focus on where we go from here. So can you just discuss a little bit about how the water district is managed, who's responsible for it, and both from in a typical year where you don't have a major project in front of you, but more importantly through a major project like this, who's going to keep tabs on it? Who's going to do things like Jay suggested about trying to coordinate and cut costs? Who's going to bid it out? How will that process work?
Okay. I haven't been through that whole process that was described to me, but Sal, you've been through it, so why don't you walk me through it also?
As far as moving ahead with this project?
But who's responsible? For starters, who runs the water district?
The water district is run by the water department.
And that is?
That answers to the town board.
Town board ultimately?
So Sal basically reports to the town board, that's all.
The town board of the commissioners of the water district.
Right. Okay.
Why don't you walk through the process? And I know this process for this particular project hasn't been finalized because it's still very much in flux. But you can probably walk through a typical process.
Of going ahead with a project
Yeah,
like this?
yeah.
What we would do, Roland could probably explain that also, as far as the bonding, what we have to do with the public hearings. Can you, we know we're working on that, but we have to have information from, GHD already on some of the seeker requirements to go ahead to get bonding.
What happens is the engineers that are retained for this project have to prepare what's called a map plan and report, some of which you've seen tonight. The town takes it to public hearing, and hopefully that's going to occur within the next 30 days, and has what's called a 202B public hearing, and at the conclusion of which they would adopt a public interest order. And that public interest order is filed with the county. That allows the town to then pass a bond resolution once we determine what the exact cost of construction is going to be, and put a nice conservative contingency on it, because we don't want to have to go through the process twice. You can always borrow less than you authorize, but you can't borrow more than you've authorized. Meanwhile, the engineers will be putting together a specification book, and then the project, once it's determined if we're going to do both priority 1 and priority 2, that project will go out to public bid, and the town will hopefully get estimates for construction bids that will be the same or less than the amount that's been authorized to be borrowed. The town then completes the borrowing, signs construction contracts, and the work proceeds.
But reading between the lines, since we're residents of Windmill are paying for it, I think what Pete's really getting to the heart of it is the town doesn't really have any incentive to necessarily get the best price for us. I mean, so wait, no. They have the incentive to fix it as quickly as possible and to do it. But there needs to be an accountability from the residents' point of view, working with the town and so that we understand the costs and we can at least have a say or an influence into that process, because there is an accountability issue. It's not.
Sure. Well,
That's part of the public hearing.
That's why we have the public hearing. This is your decisions. We're here to just provide you the experts to give you enough to make the decision. And then in the end, when it comes back to us that we feel this is confident what's going to be done and the decision is between you and us, then we're going to decide to do it.
That's not why we had this meeting tonight.
That's why we're
No,
here.
there's no doubt there's the safety issue. I'm just talking about the cost. I mean, if something costs $9 million or $13 million, the fact is, you guys are rightfully concerned with the safety, the fire, fixing all of the priorities. Your first concern isn't necessarily the cost of that.
It is.
That's
We're
more-
bound by law to take the lowest responsible bid.
Of course.
That's why you got the bid.
Can I ask a
Or to reject them all
question here?
and do it
Instead of having a separate discussion going on between these two people, fundamental question. He mentioned, Mr. Baroni, that you were thinking in terms of priority 1 and priority 2. I want to know whether or not there's been a decision made already that priority 3 goes by the boards, or is the water district contemplating that what needs to be done here is not only priority 1 and 2, but also priority 3. And in that regard, as a sub-point, are the roads that have to be constructed roads that deal with priority 3 issues, or are they roads that deal with priority 1 and priority 2 issues? Are we contemplating now a bond issue that's going to deal with $2 million, $4 million, or possibly $10, $11 million? Where is the water district today in terms of what they believe needs to be done in this bond issue?
I think the answer is that's why we're having this meeting primarily. We're giving you the information. You are the owners of this water district. And somebody, at the public hearing, whatever you have to decide, we have to decide as a group what the priorities are and how many of this, priority 1, 2, or 3 you want to do. And I think it's a cost-benefit analysis. Certainly money comes to play in this.
Well, I think the roads that have been opened are in priority 1 and 2.
I've lived here 40 years, and I don't want to be in a position where we do priority 1, and having finished priority 1, we find out all of a sudden that priority 3 is becoming much more of a priority because all of those names are going to break, and we better get to priority 3. If we take the whole idea, you don't want to ask for less because after all you have to go back again and that's more difficult. Seems to me we ought to contemplate really doing something realistic if we're going to do it at all, and that it probably ought to encompass a real analysis and stuff that we can really evaluate in terms of priority 3 before we reach any conclusion here. The other is too easy to have to just deal with.
Question. Way back when I was in the industry, I thought sewer and water could be bonded over a 40-year period. Is that still, that's not the case anymore?
No, well, I don't know about 40 years, but there's a chance that it could be 30 years, but what happens, the towns and financial advisors have to do the math involved to see the interest rates will be higher if it's a 30-year bond.
Of course.
So we have to do that analysis of which way we're better off.
I just wanted to know what municipal law was. I thought it was 40 years at one time.
Yeah, but nobody can sell a 40-year bond, so that's just not done anymore. But it's possible it could be 30.
Yep.
We have beneficiaries that use our water system, like Common Hill, Greenwood, Arnold Tennis. Would they participate in the cost of this?
Absolutely.
They would participate?
No.
Well, no. They only participate by, well, they don't participate because they just pay double the inside rate.
They don't participate?
They don't participate in the capital because they're not part of our district.
Now we just then instead of charging the tax, just increase the charge the flow of the water instead of actually having a bond. I mean, you have the bond, but instead of have a tax, just increase the rate, the water rate. Can we do that?
Yeah, I think that's normally how it's done, right?
Yeah. No, the way that it's been done up until now is you have the operation and maintenance of the district is run through the water rates that we all pay, which I think is $7.50 per 1,000 gallons.
Right.
And then the capital improvements
are split equally, not done by assessment. It's every parcel pays the same amount, and that amount appears on your town tax bill as a separate line item.
And there is no alternative to actually go and put that cost into the rates?
No.
And recover that?
Because once this district was formed back in the 70s, it was determined then with the cooperation of the state comptroller how you would raise revenue for this district. And what we told them then is binding all the way into the future.
So only then the residents of Windmill will have to pay
Right.
this.
So Roland, there's no way of reopening that?
There's no way of reopening that, and I'm not sure it would be fair anyway to charge everything according to water usage, because then the larger families would pay more for this system than the empty nesters. And that wouldn't strike me as being the fairest way to do this.
Well, another consideration there is that the schools, I'm focusing on the school for a second, but right now I think that if you were to poll parents that send their kids to Coleman Hill School, albeit the test results are what they are, I think they would seriously prefer not to have the water going into that school travel through asbestos pipes. And maybe we should consider the cost of a project like this, the burden should be shared differently than it has been in the past. So my question is, legally, can that be reopened, or is that binding and you can't touch it?
The way it is now is legally binding, but the alternative to it is to extend the boundaries of the water district to include the school. If you did that, then the school would participate in the capital expense.
But then you'd lose the usage.
And Brentwood as well.
But of course, then they would pay the inside rate for water.
But each parcel, if each parcel pays equally, it would be like adding, Coleman Hill would be like adding another house in Windmill, basically, is what you're saying.
As it's done currently?
Yeah.
Yeah, unless you, yeah.
Then you won't get anything.
Yeah, that's true.
I'd like to point out that I think it's amusing, to use a nice word, which my husband has encouraged me to do tonight, given we're new residents in Windmill, that you're glossing over the health issue here. There's no conclusive study that has ever said that asbestos is not dangerous when it's consumed into your stomach. It's actually very insidious. It nests in your tissue, and so the only way you'll know is 20 to 30 years from now, when children start getting cancer, that there's a problem with asbestos in the water. So there's no way you can conclusively know that. So for you to stand up and say there's no evidence that this poses a health risk is an overstatement at best. The reality is there's no evidence that it's not a health risk.
What we're stating is what the EPA is telling us and what the test results that we've done have shown. That's all we're stating. We're not giving you, it's not our opinion.
Howard,
50 years
yeah,
Howard,
there's
we're now starting to corrode and break, just now.
There's been studies done by the World Health Organization. This has been around 50 years, not 20 years, and it said that this kind of pipe does not create a health hazard.
Until they determine it does. That's always the problem with all of
Well,
us.
I never know.
So I don't believe what you're saying, and the reality is, and I say this unequivocally, property values will be affected if these pipes are not all replaced. I can say with certainty that I would not have bought my house in August if I had known about this issue, and that other families in town who are moving in, predominantly families that have children who will go to Coleman Hill, who will learn about this issue, will do the same. So this is a broader issue for the town, and it will impact, from a health perspective, property values, particularly within Windmill. So there needs to be a broader solution, and glossing over the health impact is really doing a disservice.
I don't think anybody's glossing over anything. He's
saying
simply
that there's no
excuse
risk
me.
to our
He's
health
simply
is
reporting.
a very bold statement.
He's simply reporting what was said to him today by
Well,
the
not only what
EPA
was
and the
said
Board
to
of
him, but
Health.
other
I mean,
studies that have been
we're reporting this information to you. That's why we're having this meeting.
You're
we're
making
trying to get an
I
understanding
assume your
of what
decision is
the
to replace
district
all the
wants.
transite pipe. I mean, that's what I hear. But that's up to you.
Yeah, if you want to replace it all, let us know. I mean, that's up to you. It's expensive.
That seems to make the most sense.
It's a
from a-
decision. That's why there's going to be a public hearing. We'll have plenty of time to revise and revision, and that's a decision that could be made. You know, it's not out of the question.
I'm sorry.
That's okay. If the pipes are now breaking, and that is the potential health hazard, how is it safe to leave them in the ground if they're broken, corroding? We live on streams, lakes, rivers, in the woods, and there's a ton of humans. How is it not dangerous to leave them there, leaching asbestos into the ground?
that we live on.
I'll let
I don't think, they're breaking, they're corroding. We saw photos of them corroding. Yeah.
One of those areas, like lot, and I'm not a health scientist, that's not my area of specialty, but having seen this stuff, it's one of those areas where it's kind of an open question. And you have to look at the bulk of the scientific evidence and the studies that have been done today. And that's what we have to go on. And in the future, science might uncover something different, that things have changed. So the common understanding amongst the health department and the EPA and AWWA is that it's largely not an issue. Now, you do have an issue. I can tell you, you do have an issue with reliability, and that these pipes are failing. It's a fact. It's happening. It happened tonight. And that is probably, at this point in time, a greater concern than the concern about asbestos fibers in the water. Now, the water department has been doing regular sampling, and they have gone above and beyond what is required of them by the authorities, the health department and so on, to do the sampling. And they're uncovering, very low numbers.
What is the total cost of the current project?
Which priority?
The project no, not to replace, the one that's underway. The one that you're
roadway.
doing. The roadway and the storm sewers.
Oh, that's not, Windmill part of it is about 835,000.
800,000 is Windmill's portion of a $1.7 million contract, which was increased. The whole road improvement in North Castle is $2.3 million.
No, but I'm just talking Windmill.
We don't pay for our portion is 800,000, but we've banked, in a sense, 300,000 by stopping the pavement. So you've got
so it's 300 to
you've got
finish.
$300,000 worth of money that will be spent by the whole town to repave these roads, because it's not a water project. So if you replace all the pipes under those three roads, you have a $300,000 benefit that Windmill District 2 doesn't have to pay for. But the next piece of road that you tear up to put pipe in, the district has to pay for the pipe and the repaving.
Unless you coordinate that with the new road paving project.
And that would be up to the town board.
Unless we're doing additional roads in Windmill in the next round.
I just have one question regarding the asbestos again, because I think that's the issue that has a lot of people concerned. And maybe Sal or the guys from GHD can answer it. If you look at any water district anywhere in this country and you test, there are going to be trace amounts of asbestos, arsenic, other contaminants that are in that water. Mm-hmm. The EPA has standards that they set for it because it's almost impossible. We're not living in Poland Spring here. You're not getting pure spring water out of the ground.
Even that probably.
Yes. So I know everybody has concerns here, as do I. But every water district that's out there tests for these things, and that's why the EPA sets standards. And again, the standards that the EPA sets is based on the best scientific knowledge that they have based on years and years of studies. But if you went and tested a water district in Somers, and tested tap water and tested it out of the mains and tested it out of the pipe, you're going to find contaminants like, maybe it's not ACP piping, but you're going to find asbestos, arsenic, fecal matter, all that kind of stuff, trace amounts in that water, correct? Is that correct or not?
Well,
I mean, for the most part, you're not going to get pure water out of the tap anyway.
The amount of contaminants that we have to say that we're required to sample for is astronomical.
Right.
When you get your annual water report that we send out every year, what you see in that report are only detects of trace amounts well below the limits. So we sample for so many more things that we're required to sample for and report to the health department.
But my point is that every water district,
there's no such thing as a pure water.
Right, you could go to Scarza, you could go to Edgemont, you could go, they very well may have transite piping, and if they don't have transite piping, they may very well have contaminants from many other things.
Or natural.
Or
the way we established these priorities was not really based on, because your water is pretty good water supply. it's based on fire flow and maintaining a pressure in the line if there is a fire when people are sprinkling the lawns during the summer. And reliability of water breaks like you have this evening. That is how we establish the priorities.
Can I ask a question about another factor that maybe should be included in that? Which is where there have been healthcare issues or health issues and liability issues, it's not been on people drinking the water so far. It's actually been on people servicing the pipes when they break. Because when they break, that's when the asbestos is released in the air, it becomes airborne, and someone can get sick. So if we keep this system in place,
you will have more breaks.
We will have more breaks, but will we have a bigger problem getting someone to repair those breaks?
I can't tell you that, what workers are going to be doing. I don't know that. But you make a good point.
Increase risks in town,
well,
or the water district. Workers on the water mains.
They're exposed.
They're exposed.
Howard, were a homeowner to dig a well, would they be excluded from the water district at that point?
I don't think you can get approval from the Board of Health to dig your own private well because you're in the boundaries of a water district. And I don't think we all could do it and abandon the system because we'd never meet the minimum separations between our own septics and our neighbors' septics. It would be very difficult. So that's not a likely prospect. I want to revisit just for a moment the idea of expanding the district to include the Coleman Hill School. There is a system where there is a way that we could get a capital contribution from the school district if we did that, to charge them for it's called a recapture program. It's a buy-in for what we've already built and paid and are paying for, the new tank, the new wells. So we could go backwards, say you pick a reasonable time, say 10 years,
Right.
and make the school district, for the privilege of getting into the district, pay an upfront capital contribution, which they might pay over 10 years, but it would defray our borrowing.
Of course, it increase.
So there is another way.
Increase our property taxes, squeezing a balloon.
Well, it's a wider base, though.
But it's a bigger base, and it makes a lot of sense.
I mean,
Question on the model.
Just what's the timeline? I mean, presumably you want to act fast on all this, especially priority 1 and 2, and I would imagine just because it's economical from a bid perspective, you're going to send out bids for all three, you're going to ask for bids for all 3 phases. I mean, what's the timeline to go out to bids and get the approvals?
Well, that hasn't been decided. That's the purpose of everybody getting together and having input. And we initially thought we might want to try and do the roads that are being paved right now. But the thought is that haste makes waste and would be more economical, again, watching the dollars, to do this carefully and develop a good bid document, as Sal said, finding where the rock is, doing the survey, correct survey, will save us money in the long term. So I don't think we want to rush this through. And there's also, if you're trying to dig ditches and then pave, as you probably know, the blacktop company will close around the 15th of November. So there's some issues there as far as getting it done in time for winter. That's why we're thinking now that we'll want to probably provide a safe road system and driveway cuts and make it so it's usable for the winter, make it through the winter, and do the correct job starting in the spring. So I mean, those issues are all on the table as far as what we're going to do.
when could we lock in the bond financing? If we
I'm
start,
sorry?
when could we lock in the bond financing and the rate for the bonds?
We have to know the amount. We have to go through a public hearing. It's a process. I would think
Couple months.
If we're trying to do a very quick job, we could have maybe done it in 2 or 3 months, but I think it's probably going to be a little longer than that, to be honest with you.
Howard, a question on the model. As of next fall, I will have lived in Windmill for 56 years. So I've seen an awful lot of changes. I'm not quite the oldest one, Mrs. Stedman is, but I think I'm second. Have you tried to take into account, somebody mentioned that we've had houses are certainly not the original models anymore and have been expanded and expanded and expanded. And I'm wondering if your model has taken into account what's left in Windmill as far as size, because that is going to create a demand on the water supply. And just one other comment. I'll guarantee that the next time we have a fire in Windmill where we have to hook up to a hydrant, we're going to collapse more pipes. I mean, the transit pipes just won't hold the kind of fire flows that are needed in a major fire.
Extent of the model. What the model can do.
Is there any wiggle room built in? That's what I'm trying to find out.
Well, the short answer is not really, okay, because we based it on existing usage, and we understood that the development was fully built out. So, on the other hand, we were very conservative, and we tend to be conservative in these type of things, so we can look at what's happening during worst case conditions, but the short answer is no, we based it on existing usage.
If there wasn't an area that was undeveloped in this Windmill Courts, we would incorporate that piece into it.
What I'm saying is that the underdevelopment is not by property lot. The underdevelopment is by house size in Windmill, because Windmill has been, over the last 25 years, Bob, I don't know, has been essentially been rebuilt, and that is going to continue, especially as the old families leave.
I understand.
And new families come in, and family size is going to increase again.
Add bedrooms, etc.
So I think you ought to put in a good pledge factor. That's all I'm saying.
That's a great point.
Well,
and there must be a way to calculate this. I don't think it's rocket science.
No, it is. You can do a sensitivity analysis.
Yeah.
Gentlemen back here after this point.
Okay, so first of all, thank you all for coming, thank you for explaining, thank you for the job you're trying to accomplish. And I think the fact that people are concerned is important, but you should get the notoriety that you're trying your best. You can't go back in time to revisit what originally occurred, what was the builder thinking. Got to go with today. So there's two issues. One is the health issue. Everybody in this room and everybody who's looking to retain property ought to be concerned with that. So we need a game plan. It's really a communications plan. It's a document that comes from the health department and any other regulatory body, not from our town, but stating, you know, we've done water tests, third party. This is what it showed. We're in good shape. Because we don't want to create a panic. So what happens is if you concern parents, especially young children, who are really concerned, and they have a right to be, they're protecting their children. So we have to protect them from themselves. Because if they start a panic, now you're going to have a financial problem that's going to make matters much worse. So we need third-party communication that states the facts as they know them. And yes, scientific evidence changes every day. You know, originally when asbestos went up in air handlers and other things like that, it was all okay. Of course, 50 years later, they found out it wasn't. So people have that in the back of their mind. So it's a very positive way of thinking, because there's a precedent. So we need to address that because it's important. The second is the financial play. And so I did some quick calculations. You know, the $13 million, it's $2,000 a household for 20 years. We need to get that communication out. Like, here's the scenario for this gentleman's concern, which is all three phases. We need to go for the biggest bond, cheapest money, and the best plan, and do it all very quickly. So the typical process of 3 months, 6 months doesn't work. This has to be a priority because it will affect everybody in the town. So a lot of times people begin to think that if it affects them, it doesn't affect their neighbor. In this case, it does. And so other people, even though they're not in the water district, if there's a panic in Armonk, in North Castle, it will affect North White Plains. It will affect everybody here. So we need a communication plan on the finances, and everybody needs to know what's going on. So from the town, do communication to everybody, not just Windmill. But say, here's what's going on, here's what we're doing about it, here's our plan, here's how it lays out, this is the process. So it's just a commentary or an observation on what is obvious. I think people are genuinely concerned on those two issues, and they want to be communicated to. It may not be what they want to hear. That's another issue. But you have to be factual. So, thank you.
Well, now to go way out of the box and really upset everybody. And congratulations, John. I've only been here 40-some-odd years. I know how long you've been. But if you really wanted to do some long-term planning, protect the value of the homes in Windmill, we should be studying a sewage treatment plant for the entire Windmill Farms in this cheap money environment. Because if you could hook all of the houses today, especially the ones that haven't been redeveloped recently, are terribly constrained in the value of those houses by the current county septic standards, the redundancies in the field. You have to put in twice as big as field, and so your house values are stymied significantly by the fact that we all have our own septic system and that cost. And if you put in a sewage treatment plant, spread it amongst 350 people, the increase in the value of the houses and the obviating of having to deal with septic systems would be pretty damn smart.
Good point.
And health issues, I mean, come on.
Well, might as well add, what about talking to the neighbors and see if we can get hooked to lines underneath?
That's what you said.
Yes, I like the ideas of thinking outside the box, and I like that idea of maybe we should dig a well, even though maybe it's not a possibility. I like the idea of rerouting the lines to include Coleman Hill. What about other ideas? Are we thinking about other options here, or are we kind of just locked in and this is it? And here's an idea, I'll just throw it out there. I'm not suggesting we should do this, but there are people that we could team up with who have deep pockets who will be very happy to help us pay for this, like Jeff Mendel. And he would love and he could probably help us nicely. Or how about other options? How about value engineering? Let's really think outside the box. What else can you do other than this option? Or are we locked in here? That's it.
And we're in this. I think that's a good question for your ROWI board. I mean, I think that's a great project for them to.
Next question.
We'll just take two more questions. This gentleman here.
So, the money, let's say the money is appropriated in a bond, there is then some sort of voting process between the members of Windmill as to phase 1, 2, 3. That's question one. Question two is, I assume it's a much less environmental risk to leave the asbestos line pipes in the ground than to remove them. So I just want to put that out there because people who are concerned about asbestos, removing them, cutting them, bringing up, would bring a lot more exposure of the rest of the environment to that asbestos.
Correct. I'd like to maybe Roland tell us the process.
There's no exact voting process. Once the town adopts a public interest order, that's the end of the public process, and then the town can go to borrowing. But I would think we in Windmill, and I've been there 56 years, almost as good as you. Whoa.
You're counting your mother, right?
Well, I grew up there.
All right.
So what happens in that instance would be you would have to give your feedback to both the town board and through ROWI. That would be an excellent way of doing it, so that the town board made the correct decision. And I think ROWI would be instrumental in getting that message back to the town board. So it's not an actual voting process.
There's no referendum among the Windmill residents whatsoever.
No, there's no referendum.
Technically, we have no say in the vote. We can certainly make suggestions, we can communicate issues, etc. But there's no vote that's cast by the Windmill members.
That's correct. But why the Board of Commissioners exists is to do what the owners of the system want to see done. So the board, the town board sitting as commissioners, are certainly going to abide by the majority in Windmill.
One more question.
Is there any point to testing, even though we don't have enough information, testing the water a little bit by a raise of hands to see if most people are in favor of doing the whole thing as opposed to doing it piecemeal?
Good.
Yeah. We can certainly do that if you think you've heard enough.
So no, just without knowing, knowing what we know, that's all.
How many people think you should do all priorities? 1, 2, and 3. When you were asked. How about priority one? Priority one. We have a choice. How about priority one and two?
I have a question.
That we move forward promptly because the interest rate environment is low.
Agreed.
That doesn't mean that the day after you get the money, you have to spend it.
Right.
You can separate out the development of a sensible plan to get this done next year, say, while we raise the money currently. So let's not confuse the one issue with the other, and move forward expeditiously to decide how we're going to raise this money and when we're going to do it quickly.
Is tomorrow night fast enough for you? You're on the town board tomorrow night to set a public hearing. Is that fast enough for you?
Yes, that would be fast enough. And in the meantime, the engineers can go forward and develop a sensible plan for which streets you do when, commencing with what dates, and by when you get the whole thing finished. One's got nothing to do with the other.